Lesson number 3, chapter 2, display data graphically. And this is called descriptive statistics. We're still in descriptive statistics. I would recommend that you use the free TI-84 calculator online. If you are unable to buy the calculator now, okay? So if you just go to the website and you click, then you will get the calculator for free online. But of course, in the test, no, you have to use the calculator. You cannot use mobile, you cannot use computer because sharing the answers, the policy, the BMU policy, okay? So, is this clear? All right, so let's go to the, what do you need to bring? You need to bring pen, pencil, notebook, or just only the worksheets, or the PDF, and use your iPad. You need a laptop for the test quizzes. In the future, bring calculator TI-84. Learning objective. Naila, please read.
Identifying graphic axis, x-axis, and y-axis, and their use and meaning. Read and interpret different types of graphics: point, line, bar chart, pie chart, circuit graph, histogram, box plot, dot plot, character chart, scatter plot, and polygon. Figure out why graphs are important.
Very good. Number 4. Dana, please read the vocabulary.
What is Dana's name? Vocabulary, key terms for statistics: frequency, frequency distribution, relative frequency distribution, frequency table, charts or graph, scale, point graph, line graph, bar graph, pie chart, histogram, box plot, dot plot, Pareto chart, scatter plot, all given. Screw to the left, screw to the right, x-axis, y-axis, outside.
Very good. This is the vocabulary for this lesson. You need to search on the internet or in the book for the vocabulary. Rules and quick review summary. Once we have collected data, then we need to start analyzing the data. One way to display and summarize data is to use statistical graphing techniques. The type of graphs we use depends on the type of data collected. Qualitative data use graphs like bar graphs and pie charts. Sometimes you call it circle graph. In quantitative data, use graphs such as histogram, frequency, polygons. In order to create graphs, we must first organize and create a summary of the individual data values in the form of frequency distribution. A frequency distribution is listing all of the data values or group of data values and how often those data values occur. Now, I make very nice drawing to categorize the two types of data, which has categorical and numerical, and under each one of them, the different types of graphs that you can apply. Okay? We will cover a few of them. We will not be able to cover all of them. So some of them, I will leave it up to you to search and learn it by yourself, like independent study. Okay? Now, if you take a look at the first one, histogram. Okay, histogram represents the frequency of each interval of continuous data using bar of equal width. We have box plot. This is how it looks like. And we have dot plot. I think we previously, in one class, we covered dot plot. And we have stem and leaf. Okay. Those are under what? Quantitative data graphs. Okay. What else can we use? We can use something called frequency polygon. And we can use what? Line graph. And also there is a point graph as well. Okay. So this is just only like a summary of what we're going to cover this class. Again, we talk about qualitative, which is called categorical data graphs. How can we represent the data using graph? We can use bar chart, can use pie or circle chart, and Pareto chart. Okay. Sometimes I ask myself, what would be the difference between histogram, which is numerical, and bar chart, categorical? In the numerical, there are no gaps. Okay, and the x-axis is numbers. Okay, in ranges. Okay, in categorical, we have gaps between each bar. And what is the x-axis is considered as like categorical, which means names. Sometimes number or date. It's okay. Okay, that's the difference between the two types of graphs, which is histogram and bar chart. Let's take a look at the first qualitative categorical. We use something called bar graph and frequency table. So an insurance company determines vehicle insurance premium based on non-risk factors. If a person is considered a high risk, their premiums will be higher. One potential factor is the color of your car. The insurance company believes that people with some colors of cars are more likely to involve in accidents. Be involved in accidents. To research this, the insurance company examined policy reports for recent total loss collision. The data is summarized in the frequency table below. So take a look here. This is called frequency table. The color, frequency. So the color here, different colors. We have blue, green, red, white, black, gray. And the frequencies for the blue, how many accidents? 25, green 52, red 41, white 36 accident, and black 39, and gray 23. Okay, so you can take a look at the numbers here and decide which one has the lowest accident. By looking at the table, which one has the lowest accident? The gray 23, right? So if you take a look at the graph on the right side here, the x-axis is the color of the car. And on the y-axis is frequency. So you can see here, by just looking, you decide which one has a lowest accident. You should notice a few things about the correct construction of this bar graph. The height of each bar is determined by the frequency of corresponding color. Both axes are labeled clearly. The bars do not touch and they are the same width. Represent the frequency of each interval of continuous data using bar of equal width. Another example here, summary of some data in the table below. You can see immediately that this graphs give you a clear picture of which category is the largest and which is the smallest. It gives a clear comparison between categories. You can also use the graph to read off information about how many are in each category without having to refer back to the data table, which may or may not be provided with every graph you see. So on the right side here, you can see the graph, and you can decide which one is the highest, which one is the lowest. And as we decided, the categories will be on the x-axis, and the number will be on the y-axis, as always. Another example here, bar graph display relationship between data and categories. You could make a bar graph impairment. You can see, look, you can compare two things. Okay, maybe to the year here, it's a year 70 to 79, and here I think it's 80 years and over. So you can compare what happened between the both of them. Okay. When you can make pictograph, a bar graph, what they call it, is just a symbol. It's also compares data, but instead of picture, the data is shown in bars that go horizontal flat or vertical. A vertical bar graph often looks like a bunch of buildings lined up. These are easy to read because you can then line them up and compare them instantly, like as you can see here. In this bar graph, the graph shows how many students use different types of transportation. You can quickly see that walking has the most students because walking has the tallest bar. A bar graph has a vertical axis and horizontal axis. Another graph, imagine you just did a survey of your friends to find which kind of movie they like the best. So here we have comedy, action, romance, drama, sci-fi. So if you look at the table, you can decide which one has the highest, which one has the lowest. And as well, if you look at the graph, it will be easier by graph, correct? And instead of looking at the numbers. So we can use bar graph to show the relative size of many things, such as what type of car people have, how many customers a shop has on different days, and so on. Now, do you understand this? Is this clear? Now it's your turn. Let me show you. Can you show me how can you graph this? Bar chart, or sometimes they call it circle chart. Okay. Can you please pay attention now? Bar chart, a special chart that uses bar slices to show relative sizes of data, also called a bar graph or circle graph. Imagine you survey your friends to find the kind of movie they like the best. So comedy, here you have the table: comedy 4, action 5, romance 6, drama 1, sci-fi 4. So as you can see here on the right side, favorite type of movies, the title, and it's color coded. So according to the percentage, what you're getting from there. So how many, the frequency, how many, what's the total here? And then you divide by all of them. 4 plus 6 is 10, plus 5 is 15, 16, 20. So let's say for drama is going to be 1 over 20. And you get the percentage and you do it here. And the same thing for the remaining. Like, for example, comedy, 4 over 20. Action, 5 over 20. 6 over 20, and so on. Okay, and you can see it. Another example here. You remember the exercise that it was given previously? Like for Coke, how many use Coke? 9 people. How many use Pepsi or they like Pepsi? 10. And Mountain View is 5. Dr. Pepper 5, and Sprite 4. How can I get the relative frequency? I have to, yes, you sum all of them up, okay? And then you divide by each category, each type of drink. So here is going to be 9 over 33. That give you what? About 27%. Okay, and so on. Now this is the percentage, but I need to get the angle. How can I get the angle? It's going to be 9 over 33. The same thing you do in the top here, you do it in the bottom. But this time you're going to multiply times 360 degrees. Why 360? Because the circle measurement is 360. Is this clear?
No.
Now you get the angle is going to be 98. So when you go and graph it, it's going to be like this, something like that. Okay, how many total students? That's the first year. Second year 420, and the third year. Okay, so the total is how much? What's the total? Yes, write the total down. And then divide each one by the total. And that gives you how much the percentage outside. So what's the first thing? Add.
Total is 1800.
Add all. So it's 1800?
1800.
Yeah, write down. Total is 1800. And then divide each one. Right. Just do it like the same thing we did here. All right, so you're done. So that's how it should look like. So you just add, you get 1800, and then you can divide. But this one is missing something. What's the percentage outside, correct? So you can do the percentage as well. How can I get the percentage? 75 divided by 1800 by itself, separate. And 420 divided by 1800, separate. And then 630 divided by 1800. And then you write the percentage outside, because the percentage is different than the angle side. Now we'll go for the second type, which is quantitative data. Quantitative data, we have different types. We have point graph. Okay, I skipped that because it's easy. We have line graph. So the same thing for line graph. All you have to do is just put the x-axis, the numbers, and the y-axis is the frequency. And then you look at the values. Like, for example, 1, how many times repeated? 8 times. 2, how many times repeated? 12 times. And so on. And then you connect the dot together. And you get a line graph. That's called a line graph. Is this clear? Any questions? If you understand, raise your hand. If you do not understand, raise your hand. Okay, and of course, as usual, I give you something to do. So you need to do this, but not now. You can do it at home, okay? And let's move on to the next type of graph, which is histogram. Very important, this one. Okay, so let me read a little bit. Histogram used to display numerical quantitative data. It is a specific type of bar chart where the categories are range of numbers. Histogram therefore show combined continuous data. Example, you have given a list of ages in years and you need to show them in a graph. The ages are, and here are the ages, okay? Is it in order? No. So you need to put this in order, okay? You can choose to group them into 10-year age category. For example, from 0 to 10, 11 to 20, 21 to 30. So each one of them give you 10, correct? And then you see the frequency for the group of data that is given, okay? And then after this, you do the histogram. The histogram, it has to be touch. There is no gaps, okay? Histogram shows us frequency over interval, and histogram can really give us an idea of the shape of our data. Let's do a quick example here. It's going to be easier to talk about histogram. An example of a histogram. Define, here I have some questions here that they are very nice. Define frequency distribution in statistics. What does it mean? Frequency distribution is a table or a graph that displays frequency of various outcomes or values in the sample or population. It shows the number of times each value occurs in the data set. How can I construct frequency distribution? To construct frequency distribution, first organize the data. Decide on the number of the classes. Okay. Calculate the class widths. Create class interval. Count the frequency of each for each interval. Create frequency table. Last and optional, visualize the data with graph like histogram or bar chart. Okay. We have different types of frequency distribution. We have group frequency distribution, ungrouped, relative frequency distribution, and cumulative frequency distribution. It shows you what type, each one of them describe itself. So you need to go through this. Let's take a look at one of the examples here. Make a frequency distribution table as well as the curve of the data. So he's giving you a set of data here. To create a frequency distribution table for the given data, let's arrange the data in ascending order. What's mean ascending order, Nagla? From small to the largest. So we start with 13. And you end up with what? 62. Now we can count the observation for interval. From 10 to what? 20, 20 to 30, 30 to 40. So we'll go by how much? By 10. And you take a look at the data from 10 to 20. How many times is being repeated? Now you go and count. How many times? 10 to 20. 7 times. Okay. So actually here it's not showing. This is not the correct data. This is another data probably. So as you can see here, 10 to 20, we have 7. 20 to 30, how many? About 10. 30 to 40, 10. 40 to 50, 10. 60 to 70, 50 to 60, 10. And 60 to 70, how much? About 3. Now you make the curve. And that's called histogram. Now this is the most important one in graphing. You can see it is coming on the test. The histogram has curves sometimes. Okay, as you can see, the first one, it's called normal A distribution. Okay, this one on the left side. It's a symmetric and bell shaped. It looks like a bell. And data concentrated around the what? The mean. Skewed. What's mean skewed? It's not symmetric. Can be positively skewed. Right tail. Which one is right tail? This one is right tail or the left tail? Right tail. The tail is here. So it's called right tail. And this one, what is the tail? On the left. So that's called skewed to the left. Because most of the data were on the right side. On the right side, yes. Now we go for the second one. Here we have like a camel, right? With 2 hop. It's called bimodal distribution. Okay, 2 distinct peaks or modes in a frequency distribution. Another one. Now how many hop here? 3. So they call it multi-model. More than 2 distinct peaks. You know the peaks, right? We learned about the peaks before. The last one here is called uniform. Uniform means all of them, they are equal. You can see the line. Now this is called exponential distribution. This one is called long normal distribution. It's like logarithm. And this one is called power law distribution. Okay? And the meaning for each one of them and the description is written here. Okay? Now, I want you to try, don't worry about this one, but can you try this one? Create a histogram for the following test. Try to do it now. First, what should you do? Put the number in order, yalla. Ascending order. From small to the large. So what's the smallest number?
25.
Yalla, put 25. So the first one is what? 25. What's the second one?
71.
So you have 25 and then you cross it out. And the next one is 71.
Yes.
Cross it out. Then 77. Cross it out. And then 80. Then
81.
and then
84. 88.
then 88. Then 94. 97. 99. Now choose the number of bars. How many bars do you want? How many rectangle you want? 4? Okay. So let's say write down here, choose the number of bars, write down 4 bars on the paper, write 4 bars. Step 2, use a nice little formula, bar width equal high minus low. What is the highest value? Minus the low. Which one is the lowest value?
25.
Yalla, write it down on the paper. 99 minus 25.
Okay.
How much that if you subtract?
74.
74?
Yes.
74 divided by 4. How much?
18.5.
18.5. We will not take the 0.5, we'll take the number after that. What's the number after that? 19. So round up. You see it's written there? Round up. Even if it's 18.4, it's still round up, go to 19. Is this clear or not clear?
Yes.
Najla? What is Najla? You clear?
18.9.
So we are in step 2 now. So what do you get? 19.
19.
So the width of the bar is going to be 19. Now, step 3, starting value is doing 0 before the lowest number. What's the lowest number?
25.
So instead of 25, we're going to start with what? 24.5. Now, draw the label for the x and the y axis. What is the x axis?
Scores.
Test scores. And what is the y axis?
Frequency.
Okay, so the frequency, put the frequency, how much the frequency? So you have 19. So from 25, the first, we're going to start with 24.5. So in the bottom here, write down 24.5. And then from 24.5 to where you're going to go?
99.
Plus 19, correct? Because the width of the bar is going to be 19. So add 19 to 24.5. How much you get? 43. So it's going to be 24.5 to 43.5. So here is going to starting from 24.5, okay, dash 43.5.